Session 10.2, the chi-square test for goodness of fit. For the session 10.1, we introduced the basic ingredients for testing with categorical variables. And for these sessions, we're going to combine it together. Use the chi-square test for the goodness of fit test. Goodness of fit test used to determine whether the distribution of a categorical variables follows a proposed distribution can be applied when you are comparing the distribution of counts of one categorical variable with a distribution of expected counts. Goodness of fit test, we do have a 4-step. First one, hypothesize. We're gonna state the null hypothesis. The population distribution of the variable is the same as the proposed distribution. This means like the equal. Okay, just like the chapter 7 to chapter 9, we mentioned about the null hypothesis is always equal. Alternate hypothesis, the distributions are different. And then prepare. We need to state the condition. First, random sample, independent measurement, large sample. The expected count at least 5 in each cell. So make sure you guys check the expected frequency for each category, at least 5. And then we're gonna use the calculator to find the chi-square statistic and also the p-value. K represents the number of different categories or cells. When we're working on the chi-square distribution, we still have the degree of freedom. Just like the t distribution, there will be k minus 1. Okay, keep in mind, not the n minus 1. For the chi-square distribution, there will be k minus 1. K represents the number of the different categories. Interpret, you're going to find out the p-value and compare with your significance level. And then state the conclusion. If you guys using the TI-83 plus calculator, you're going to follow this step to find the test statistic and p-value. If you're using the TI-84 plus, then you're going to follow this instruction. Okay? Let's try to do this example. Goodness of fit, toasted die. A 6-side die was toasted 180 times and the data is shown in the table below. Test the hypothesis that the die is not fair. Use a significance level of 0.05. So, we performed the experiment and we rolled the die 180 times already. And this is gonna be our result. This is the observed frequency. Now, let's calculate the expected frequency. Okay, we believe this is gonna be a fair die. So we do have the expected frequency are equal. Okay, the n will be 180 times. K, that will be the number of different categories. So K is gonna be equal to 6 in here. So we'll plug it in. You're gonna get 30. Okay, right? Observed frequency and the expected frequency. Now, we're gonna state the hypothesis. The null hypothesis, that will be the die is fair, okay? There will be about the same number of toasting results in 1, 2, 3, 4, 5, 6. Means they do have the equal frequency on each of this number. Then the die is fair. And then alternate hypothesis. The die is not fair, okay? The distribution of toast differs from what we expect if the die is fair. Okay, right? Hypothesize. Prepare. We're gonna state the condition. Our expected counts are all greater than the requirement minimum expected count of 5. So each expected frequency at least 5. So this is good, right? Now we're going to use the formula to find the test statistic. On the exam, I let you guys use the calculator. Okay, I'm gonna show you guys how to use your calculator. So chi-square will be equal to 11.2. Okay, find out the degree of freedom. Okay, make sure that's a k minus 1. Okay, that will be 6 minus 1 equal to 5. You also get the p-value 0.0476. Okay, right? Now, use your p-value compared with your significance level. That will be reject. And then we're gonna state the conclusion. There is sufficient evidence to support the die is not fair. Okay, we reject the null hypothesis, so we know the die is not fair. Okay, right? Now, let's try to use the calculator. I'm using the TIA 4 plus, so I'm gonna use this part, the second part, okay? Okay, go to the L1, edit 1, number 1 edit. Let me clean up all the data first. L1, you're gonna input the observed frequency. L2, you're gonna input the expected frequency. Okay, observed frequency. Expected frequency. Okay, right? And then go to the stat, go to the test, go to the chi-square goodness of fit test. Okay, if you're using the TI-83 plus, you don't have this guy. So you need to follow the instruction from the top here. Enter. So my observed frequency is on L1, expected frequency is on L2. That's good. The degree of freedom, you have to do it by yourself, okay? Don't trust your calculator here. Okay. And then go to calculate. So you're gonna see my test statistic is 11.2 and then p-value 0.0475, okay, 0.0476 here. They have the degree of freedom. Hey, one more time, degree of freedom, don't trust your calculator, do it by yourself. Okay, so this is the goodness of fit test and we're working on the equal expected frequency. Example 2, let's do it together. The ethnic breakdown in a certain community is 60% white, 20% Hispanic, 10% Asian American, and 10% African American. Suppose 200 people are called for jury duty, and the ethnic breakdown of the potential juror is shown in the chart below. Does the ethnic distribution of the jury pool match that of the community? Use a significance level of 0.05. So you can see every category, this specific state like the percentage. So you know that they do have an unequal expected frequency. Okay, so we're gonna use this formula. The white, that will be n times the p1. Okay, n will be 200, p1 for the white will be 60%, so it's gonna be 0.60. So the first expected frequency for the white will be 120. Second one, the Hispanic, 20% Hispanic, so 0.20 times the n, 200, equal to 40. Okay, I want you guys to finish these two also. Okay, you should get Asian America, equal to 20, African America, equal to 20. Okay, write it down here. Double check when you add it all up, it has to be equal to your n, which is gonna be 200. Okay, state your hypothesis. The null hypothesis will be the authentic distribution of the jury pool match that of the community. Okay, match that of the community means like they equal. So alternate hypothesis, that would be different, right? The ethnic distribution of the jury pool differs from that of the community. Okay, prepare. All expected counts are greater than the required minimum of 5. So double check all the expected frequency at least 5. Good, right? And then use your calculator to find the test statistic. You should get this guy. Degree of freedom. How many characters do we have? We have 1, 2, 3, 4. Okay, so k is equal to 4. 4 minus 1, which is 3. P-value. And then use your p-value to compare with your significance level. So we're going to reject. Conclusion. There is sufficient evidence to support the ethnic distribution of the jury pool does not match that of the community. Okay. Double check, use your calculator. One more time. L1, you're gonna plug in the observed frequency. Expected frequency will be on your L2. Go to the stat, go to the test, go to the chi-square goodness of fit test. Okay, again, degree of freedom, you're gonna put it by yourself, which is gonna be 3. Go to calculate. So, my test statistic will be 10.03. Degree of freedom, that will be equal to 3. P-value, 0.01828. Okay, right? Okay, try to work on this example by yourself. Okay, a package of 100 candies are distributed with the following color percentage. 11% red, 22% orange, 13% yellow, 11% brown, 25% blue, and 80% green. Use the given sample data to test the claim that the color distribution is as claimed. Use a 0.01 significance level. Okay, first, let's try to find the unexpected frequency. You're gonna use the n times the p1, okay? So n will be 100, okay? Either the given the n here, or you could add it all up for your observed frequency. That would be your n. So it should be equal to 100 also. 100 times the red is gonna be 11%. Okay? So check your work. You should have the expected frequency like this. Double check it, add it all up to see if it's gonna be equal to 100. Okay, hypothesize. The null hypothesis will be the candies of the color distribution has claimed. Okay, will be equal to what they claim in here. Alternate hypothesis, the distribution will be different. Okay, prepare. Require Expected frequency is at least 5. Okay, double check at least 5 for each category. Good. Then use calculator. You should get the test statistic 3.09. Degree of freedom, how many characters do we have? 1, 2, 3, 4, 5, 6. Okay, so degree of freedom will be equal to 5. P-value, that will be equal to 0.6861. Okay, so predict break p-value. And then compare with your significance level. So that will be fail to reject null hypothesis. Conclusion. There is not sufficient evidence to support the claim that the color distribution is not as claimed. Okay, right? Pretty straightforward for these sessions. That's it.